Okay, good afternoon to all of you. Welcome to our Calculus 2 course, MAT162. At Bethany, LD Woosley Bethany College. We're just waiting for our student to come in. We're live here on our CBC Ministries online PH on our YouTube channel. Okay. So just wait for our student to come in. Yeah. Okay. Anyway, this calculus 2 specifically integral calculus, but this is not entirely integral calculus. In fact, this will introduce to aspects of differential equations as it is connected to calculus 3. Yeah. So we'll have a review today of differential calculus, some various derivatives. Let's just wait for our student to come. Perhaps while waiting, we could, I need to type something here. So the other term for integral is antiderivative, no? Or antiderivative. So assuming that you have a function, say f of x, say f of x is equal to 3x squared, or you have a derivative here, no? So if we have a function of f whose derivative is f of x. Now, for instance, if you have here a function so I just pull down here your math calculus editor. So we have f of prime. F of prime is equal to d over dx of x cubed. This is obviously equal to, so your f of x there is 3x squared. So then, if we will go back to its original, that is fx. So f prime of x, or the d of x of x cubed, the first derivative of x cubed is 3x squared. And then we will go back. So it follows that if x is equal to x cubed. It follows that that f prime of x is equal to derivative of x cubed, which is 3x cubed. It follows, no? It could be the other way around, no? If f of prime, based on this analogy, if f of prime is equal to 3x squared, then it follows that your f of x is equal to x cubed. And the only way to reverse this process is what we call antiderivative, or sometimes we call it integration. Okay, integration, mga kapatid. The other way around, no? So that's the reverse of integration. Integration or antiderivative, that's how we call it. Antiderivative is the opposite operation. Oh, good afternoon, Gillian. How are you?
Good afternoon po, sir. Okay lang po. Sorry po, late. Galing po ako sa labas.
Okay, we're discussing here as a review of the relationship of derivative and what we call antiderivative or integration. For instance, if you have f of x equal to x cubed, it follows that f of prime of x is 3x squared. So it follows that if the derivative is 3x squared, then the function would be x cubed. How will you do that? Because this is the integration process or the reverse of differentiation. So integration or antiderivative is the opposite. The opposite operation of derivative. Ay, teka. Parang umuurong ako. So by Friday, okay lang Gillian, by Friday we still meet. Pero next week, Wednesday na lang tayo kasi medyo naipit yung schedule natin ng Friday. For me, it will be sandwiched to 2 courses, solid. Yung solid, di ba, would start by, anong oras ba yun? 7:30 or 8 to 9:30. Actually, kapos siya eh. No, kaya lang, sige, tingnan natin paano natin may i-squeeze yun. And then, I have my Edu 115 class by 9:30 to 12:30. By the way, we schedule a reporting in Edu 115. Have you seen your classroom, Gillian? Have you seen your schedule for Edu 115? I already assigned, you will be assigned to present module 2. Ayun, nawala. Yeah, let's wait. Ayan, nag-brown out yung estudyante ko. Alright, ano kaya to? So, I will be on monologue. Anyway, let's continue. Okay, so, sige, tuloy tayo. Kahit monologue mode muna. So, it follows here, the function f, function f of x is an antiderivative of f of x. Because your f of prime is supposedly, this is also equal to f of x. And f of x yan. So the antiderivative of f of x is f, or capital F of x. So anyway, those are just notations. Okay, so these are just notations that we may have derived. Of course, there is a specific interval, no? There's a specific interval, the function. So, by definition, formal definition of antiderivative, a function f of x, capital, is an antiderivative, meaning there are a lot of antiderivatives. There are a lot of antiderivative. There is. So it is an antiderivative. On an interval, no? So we have an interval here, no? A specific values or interval. Interval I, and f of prime of x is equal to f of x. Okay, this is for all x. For all x in an interval I. Alright? So yun yung ano natin. No? Let's have some sample here. Note that f, or the antiderivative of f rather than the antiderivative. No? So it's an antiderivative. So maraming pwedeng mga antiderivative. No? So there are possibilities. No? So malalaman natin yan sa nature. No? So for instance, bakit siya naging an? So, yan, an. Hindi siya di. An, mali pala ang highlight ko. An. So, isa lang siya sa mga derivative o antiderivative ng function f of x. Alright? So, let's consider this function. A f of 1 f of 1 of x, say these values, no? X cubed. Okay, another value would be f of 2. F of 2 of x is equal to, say, x cubed minus 5. And then another function, f of 3 of x would be equal to, say, x cubed plus 97. All right, so what could you notice here, no? If we will try to get the derivative of these antiderivatives, so we will result to the function of, or the function, no? We will be resulting to the function. So papansin natin yan, Now, if we will solve for, if I will continue on this, it follows that your f of 1 of x is equal to f of 1 prime of f of x, which is the derivative. No? So we know the derivative here is the derivative d over dx of x cubed, which is equivalent to 3x squared. Right? Okay ba guys? Nakita ba? Same as true with this one. If I will try to solve the f of prime, of x, this will result also to, because negative 5 is a constant, so it follows that, sige, tuloy lang natin. So this would be x cubed minus 5. So what will happen? Obviously, this will also have an answer 3x squared. Alright? So same. So meaning kaya siya naging an antiderivative because there are many possible antiderivatives for a given derivative. Ayan. So how about the third one? Same as true with the third one. If we will compute the f of prime of 3, so this would be the derivative of x cubed plus 97. So again, 97 is a constant, so it follows that the derivative would be 3x squared. Okay? So what you could show here, it follows here that a particular function f of x has many antiderivative. Ayan, welcome Gillian. So buti bumalik ng power.
Opo, sir. Opo.
Okay.
Nag-brown out.
Okay, no problem. Anyway, recorded to, you could always go back. Now my point is that yung definition natin ng antiderivative, na derivative is an, it is not the, the. So let me emphasize this. This is an antiderivative, not the or the. Now bakit? Kasi hindi lang iisang antiderivative ng isang function. Considering the example that we have here, the first function, f1 of x cubed, if you will look for the derivative, that is 3x squared. All right? And then f2 of x is x cubed minus 5. Obviously, the derivative would be 3x squared also. Same as true with the f of 3 of x cubed plus 97, the derivative is still the same. So hindi siya, there are infinite possible antiderivative of a function. That's the point there. Now that's why sometimes we may have a general solution. Now we may have a general solution on this by generalizing all of the constants. As you can see, f of 1 has a constant of 0, f of 2 has a constant of negative 5, and f of 3 has a constant of positive 97. So we could generalize this, no? So we could have a generalization such that the antiderivative or the integral of f of x dx would be equal to f or the antiderivative plus c. So to be more general, no? Because the antiderivative that we're solving in a given function is has basically an infinite number based on this example that we have. No? So all of them will have the same derivative. Now, whether it's f of 1, f of 2 here, and f of 3. Now, it will reverse the process, and this is the symbol for antiderivative. We will make a general answer or general solution. Now, we may have a general solution to represent all of the possible antiderivatives or integral of a function. So the C here would represent this a constant that would represent all possible values for letter C at a given interval. So that is kaya ngayon kaya tayo naglalagay ng plus C sa integration dahil napakadaming antiderivative ng isang function. Okay, make sense Gillian? So kaya tayo nagpa-plus C doon.
Yes po, sir.
To represent all of the possible antiderivative or integral of a function. Similarly on this example that we have. Okay, let's have some checking here. Perhaps we could finding the antiderivatives, no? In fact, if you're in your PDF file, I'm placing it here. For instance, if you have letter A, okay, letter A, say f prime of x equal to 2. Okay, so solving for each derivative, describe the original function. So this is actually your original f of x. And then we are going back solving for the f of x, which is the capital F or the antiderivative. Okay, any idea, Gillian, what's the answer? What will be your f of x?
X squared po.
X squared, okay. X squared, because so x squared na walang plus. So of course, it will add a general term. So for a general solution, it will be x squared plus c. X squared plus c because the derivative of x squared plus c is always equal to 2x. Right? So lalagyan na natin siya ng general solution. So general, or what we call sometimes the general solution is the indefinite integral. So meaning we will not set the boundaries yet, but of course if we will define the boundary, then we will have a definite integral for this. Okay, next, perhaps you could, if you're referring to letter B, the exploration, f prime of x is equal to x. What will be your f of x? Okay? Halos katulad ng letter A yan.
Ano ba? X squared din. Ay, hindi. Diba po, sir, pagpabaliktad, magpa-plus 1 po.
Think of a function, but then you get the derivative is x.
dx po, sir? Ay, hindi. Mali pa.
Anti-derivative tayo. Derivative yun. Antiderivative.
Pabaliktad.
Hmm.
1x1. X plus a constant po ba siya?
That is, x lang. Kasi pag kinuha mo yung derivative ng x is 1. So, hindi na siya x. Katulad lang halos siya ng letter A. Nagkatalo lang sa constant. Oh. Kaya lang siya x squared kasi may cancellation, di ba?
Opo.
Oh, so ano sagot? This is x squared over
2.
2. Oh. Pag x squared, binaba mo yung 2, kunin mo yung derivative ng
Oo
cancel.
nga po. Nalito ako biglang.
Kalimot ah. Ayan, so plus pa rin yan, no? Because we're using indefinite integral. Next. Oh, ito naman. Sige, laktaw tayo. Letter E, 1 over x cubed. So, kung ang f of x mo, letter E tayo. Anyway, it's on your book. It's 1 over x cubed. Ayan. So, ano ang magiging f of x? But of course, for you to make this easier, so this could be expressed in terms of x raised to negative 3.
Negative 3.
Yan.
Plus minus 1. Negative 3 over ano po? X raised to 4 po.
X raised to 4, positive.
Opo.
Negative yung function. X raised to negative 3.
Ay! Ano? Mali pala. X raised to negative 3 po, no?
Yes, or 1 over x cubed.
Opo. Bali po negative 3 over x to the 4th po.
3. Let's try
Opo.
Negative 3 over
X raised to 4 po.
ganito.
So, opo.
Pag binaba mo yun, magiging x raised to 5 yan. Oh, when you get the derivative, x raised to negative 5, bababa ang negative 5, matitira. Or negative 4, minus 1. Automatic yun, mag-minus 1 yun. So negative 4 minus 1, negative 5. Mas mapapalayo.
Baliktad po ginawa ko. Integral po, sir, di ba? Kapag antiderivative. Okay. Nalilito po ako, sir. Hindi ako sanay tawagin na antiderivative.
Anyway, we're just exploring because we know, it is assumed that we know derivatives. We're just doing the reverse. Parang ganun.
minus 1, minus 2. Ano po, sir? Negative 1 over 2x squared.
2 or 3? 2?
2 po. 2x
2.
squared po.
2x squared.
Apo. Yung denominator. Okay.
Okay yan. Test nga natin kayo octave kung tama.
Pwede po sa octave yan, sir.
Oh, yes. We'll just use diff and symbolic functions. Since x, it's a first preparatory command, meaning you make the variable symbolic, and then you have diff of 1 over or negative 1 over 2 times x. Well, tingnan natin. Ayan, walang nangyari ah. Oh, negative x, ang lumabas. Ay, hindi ko pala, mali ako. Hindi ko nalagyan ng negative. Dito. Kasi din, may negative ko doon. Yun, sakto. Yan, 1 over, so the answer is 1 over x cubed. Okay, so the command there is diff. But you need a preparatory command to symbolize. Though there are many ways to symbolize an x. Now, pwede rin naman yung katulad kanina, diff. Wala. Yan, diff. So you have, say, so quote x squared over 2. Right? And then you have that one. So meaning, this is symbolic also. Ayaw niya. Kasi nga naka-symbol, na siya, symbolic na siya. So no need na pala. Symbolic na siya. Yan. So ang sagot ay x. Yan, symbolic x. So pag yung kanina, yung diff of x squared lang, ayan, 2x naman. Ay, nakikita mo ba? Parang hindi, no? Nakikita mo yung sagot?
Nakikita naman po, sir.
Nakikita so far. No? Ayun, medyo nakaangat pala ng konti. Kala ko natatablo. So yan yung conjuice. For integration naman, int or int or integral of x. So pag wala kang from lower to upper limit yan, so automatic indefinite integration siya or antiderivative. So babalik ka dun sa x squared plus 2 or over 2 rather. So and then you have int of 1 over x cubed. Okay. So negative 1 all over 2x squared. Tama rin. So pwede siyang mag-reverse. No? Alright. So those are some of the exploration. Okay. I don't need to be purely theoretical here. No? So yung idea ng paglalagay ng constant ay this is for generalization. Meaning, it's not a specific solution or a particular solution, but a general solution. Since that is an indefinite integral, meaning there are no boundaries. So the boundaries would define a particular area. No, kasi nga, ang analogy ng integration, I just would like to share the analogy of integration. Perhaps you have a function here. This your x and this your function. So meaning, ang idea ng integration, nanginginig to. So the function would be chunked into an interval. and you will compute each of the interval by trapezoidal rule, meaning approximately there is a trapezoid that will be formed in every section of the function. Now, if there is no boundary set, for instance A and B, hindi natin masasabi yung particular area unless you will set a particular point point A and B, which is the lower and upper limit of a function. That's the time you will have a definite answer. No? But for the meantime, since we don't have, for antiderivative, it's more on indefinite integration, meaning we don't set yet the values of for A and B, such that we could compute for a particular area of the function. So, ito yung area function mo. No? So, yan. So sinusukat niya yan kada so meron kang it forms a trapezoid actually. So each section composed of will form an approximate trapezoid. Imagine mo nakatabingilan to, no? Pero pag binaliktad mo yan, trapezoid yan. So lahat yan, no? So from A to B, so kukumpitin niya yon. So that's the implication of integration in a function. You're actually solving for the area covered by that function. Okay, makes sense, Gillian? So that's how we interpret integration. Unlike differentiation, in your recall, how will you geometrically present differentiation or derivative?
Derivative. Nakalimutan ko. Ang naalala ko lang yung integration.
Wala. Lagot ka sa calculus 1 mo.
Ang tagal na kasi, sir, 2014 pa. Hindi ko na maalala.
Ang ano naman, so eto naman, we are actually solving for the So yung ano natin dyan, so this is your function of f of x. That's how the geometric presentation from A to B. So may lower limit ka, may upper limit. So that would define the area. Ngayon, pag sinabing differentiation, halimbawa curve, at a particular point, it's the slope. Now, the derivative, the f of prime, is actually the slope at that particular point. At any values of x, at x. So, or of course, kung yan ay meron ding value ng corresponding value of y. No? So, meaning, at that particular point, there is a slope that is tangential to the curve. No, it will not cross at 2 points of a curve, but once on that particular curve. Point on the curve, that's tangent. Yeah, ito tangent din to eh. This is also your tangent function. So yan naman yung interpretation sa derivative. Okay? So derivative is more on the slope, no? Perhaps normally ginagamit natin yan sa mga instantaneous application, no? In velocity, acceleration, even in mechanical systems, no? Or electrical systems, may mga differentiation. Pagdating naman sa integration, yan, ang geometric idea niya is covering the area of that function. Now, that covers the area. Okay? So, of course, geometrically, hindi natin mapapakita na opposite sila ng ano. So, medyo mahirap ipakita. Though may correlation pa rin yun. May correlation pa rin yung geometric presentation ng f of x, which is the antiderivative, or f of prime of x, which is the differential of a particular function in a particular point. So there is a singular point that is tangential to the curve, or a line that is tangential to the curve. That's your tangent line, and that is the function of the derivative. Okay, so yan yung recall natin, no, sa ating differential calculus. All right. I think we could recall some, let us recall some of your difference. Tingnan natin kung, have you seen the exercise 5.1? Ano? Have you seen that 5.1 exercises?
Yes po, sir. Bali, nasagutan ko na po ata yung even numbers up to 12 po.
Even numbers. O sige, let's look. Yung 5.1. So, teka, baka meron lang akong, anyway, some of these are, siguro ipo-pull down ko yung basic integration rules. So this is your book, no? I will just pull down the, no? So by the way, this is used for solving differential equations. Now, one way of solving differential equation is through integration. I don't, siguro hindi pa umabot dun yung ano, no? Yung math mo sa Adamson, ano, Gillian. Have you taken differential equation or not yet?
Bali, opo, sir.
Umabot ka differential?
Nakadalawang take po ako na.
Oh, yun. Isa doon yung tinatawag na variable separable or separation of variables. We use integration. No? So, yan. Kaya dito, nabanggit dito sa book. Example, solving a differential equation, y prime is equal to 2. So, one of the antiderivative of 2 is 2x, but it could have a general solution, no, which is 2x plus c. No? So, if c would be equal to 2, 0, or negative 1, so that would represent the family of lines that is parallel. No? There is ang slope nila dyan ay 2 because it is in the form y is equal to mx plus b. And your constant is your intercept, the one that would intercept your y, no? If I'm not mistaken. So yeah, katulad yan, at c is equal to 2, it will intersect y at 2. Kapag ang c mo 0, it is on the origin. Pag negative 1, it's on negative 1, y is equal to negative 1. So that's in the form y is equal to mx plus b. Naalala mo pa yon sa analytic? Gillian?
Slope po.
So we could have a general solution by putting plus c. Yun nga, katulad ng example natin kanina. Kasi maraming antiderivative ang isang function. Actually, it could be infinite number of antiderivative. However, to represent generally, we put the plus c as far as our general solution. But of course, there is a particular solution provided that there are boundaries. So, yan. So, yan yung ating ano dyan. Okay, solving for differential equation. So ito yon. So, dy over dx equal to, actually ito, nagkaroon lang ng manipulation. Dy over dx equal to f of x. So, nagkaroon ng manipulation. There's our manipulation. Ayan. So this would be the way we could express this. Y is equal to integral of f of x. This is your function, or sometimes we call it the integrand. The one that is to be integrated is the integrand. Parang radicand lang, no? Para lang siyang radicand. O yung integrand. And then of course the variable of integration, this is the very basis of your integration. Ngayon kung babalik tayo doon sa sa illustration ko kanina. Anong rin-represent nun? Yung ito yun, no? Yung kada ganito, that's your dx actually. Yun yung difference nun, differential. No? And then yun yung hinati mo yung dx yan, that's the representative slice of that function. No, kaya nga yung ibang mga illustration, merong kumukuha sila ng isang bahagi na, I don't know kung nakikita mo to sa ibang libro, kumukuha lang siya ng ganyang portion, and then tinatawag silang dx, and then maaring y itong tawag dun sa isa. So yung product nila, that's already an area. And then you sum it up depending on the lower upper limit. That's the definite integral. Okay, so yun, maraming relations tayo makikita dito eh. So of course, the resulting function would be an antiderivative of f of x. So it's not the or the antiderivative, but an antiderivative of f of x, because there is will integrate the constant of integration for general solutions purposes. That's why sometimes we call, most of the time we call antiderivative as integral. Integral. Indefinite integral is synonym to antiderivative because we don't, hindi natin sinet yung boundary in the upper and lower limit. Okay? So these are basic integration rules. So of course, yung f of prime of x dito, this is your f of x, small letters. No? So of course, definitely this will cancel, but there must be a constant of integration. Or integration is the inverse of differentiation. Ayan. Nagkakaroon lang ng maraming antiderivative, pero yung derivative of a function, iisa lang yun. Kasi pag kinuha mo yung slope, isa lang naman yung slope at a particular point of a curve. Definite siya. No, kaya pag kinuha mo yung differential ng isang function, isa lang siya. Pero pag kinuha mo yung antiderivative o yung integral ng isang function, meron kang constant. Bakit? Kasi hindi mo alam yung area eh. 'Di ba? Hindi mo alam yung eksaktong area ng function. No? Kaya meron kang constant. That would be a general solution. Unless otherwise, there is already a lower and upper limit for you to have a definite integral. Okay, but since it's indefinite, there is a general solution. To represent the general solution is to put attached letter C. So maraming antiderivatives, pero pag kinuha mo yung derivative of function, isa lang yun. Okay, so tandaan mo yan. Yan. So there are integration formulas here that we could consider. Plus it's parallel differentiation formula, no? So by this time, Gillian, dapat ano mo na to, medyo masaulo or perhaps ma-recall.
Yes po.
So we know that for on differential, the derivative of a constant, any constant at all is 0. Therefore, in reverse, the integral of 0 is equal to a constant. Okay? So meron siyang, so wala nang plus C doon kasi absorb na ng plus C. Now, the derivative of constant plus x is equal to the derivative of constant plus x, constant kx or variable kx equal to k. The integral of k here is kx plus c. So, saka ka maglalagay na ng plus c doon. Of course, just, so this is a general term, k times f of x. Its derivative is k, f prime of x. So, dito naman, so meron kang, so it could be that way, no? K is also, hindi siya tinatalaban ng integration differentiation operation. So si K malayong nakakalabas with inside and outside the integration or differentiation process because he is a constant. So pwede siyang pumasok, pwede siyang lumabas. Ganun din sa integral. Pwede siyang pumasok, pwede lumabas for the integration. Of course, the integration follow also some of similar properties for your differentiation, like this one. These are properties for addition and subtraction, no? In terms of the distribution of the integration or differentiation. So here, this is the differential of a sum is equal to the differential of the addends, the sum of the differential of addends. Kumbaga, yung sum, pwede mong kunin muna yung sum bago mo kunin yung derivative. Katumbas din siya ng derivative ng bawat addends o yung mga dinagdag mo. Same rule applied to your integration. You could always distribute integral provided that it is separated by a plus or minus operation only. So hindi mo siya hinahalo. No, hindi mo siya kumbaga hindi mo hinahalo yung multiplication division. So plus minus pwede mong i-distribute ang integration. Alright? So yung kanina, yung sample natin, ito na yon, yung power formula. So differential of or derivative of x raised to n is n raised to n minus 1. So marami tayong example kanina, some sample. So pag i-reverse mo yan, integral of x raised to n would be x raised to n plus 1 all over n plus 1. So for integration, you're subtracting the exponent or power. For integration, you're adding to the exponent. However, same will be divided. No? The same numerical exponent will be the one that will be divided. So if in this case, so you have x raised to n plus 1 divided by n plus 1. For instance, integral of x raised to 5 is equal to x raised to 6 over 6 plus c. So that's what we call power rule, no? Power rule. Okay, another. Of course, we will apply this to trigonometric functions as well. So I hope and pray that you still memorize your trigonometric function. So mahalaga yan. So mamaya mag-upload ako ng mga formulas for consideration mo. Mga formulas for review na rin. Okay? So yan, derivative of sin x, cosine x. However, same as true, if you get the integral of cosine x dx sin x plus c. So pareho lang. Ito naman, derivative of cosine is negative sin of x. Therefore, the integral of sin of x is negative cosine of x. So binaling niya lang sa kabila yung negative. Alright? So nagkakaroon lang na negative kapag may integration ng sin of x. Kasi on the counterpart of the differential calculus, cosine of x, the derivative of cosine of x, negative sin. Yes. Okay, tangent. Ayan. Tangent, secant squared x. Integral of secant squared x is tangent x plus c. So don't forget the plus c. Same as true with the derivative of secant x is secant x tangent x. Integral, therefore, of secant x tangent x is secant x plus c. Same as true with cosecant. Negative cosecant yun pag kinuha mong derivative ng cotangent. So magkakaroon, lumalabas yung negative doon sa antiderivative na. No? So pwede rin naman yan. Halimbawa, pag may negative sign dito, wala nang negative dun sa kabila. So isa lang. No? So kung negative of integral of cosecant squared x dx is positive cotangent x plus c. So yun yun. So isang side lang yung merong negative. Ganon din sa cosecant. Now, of course, the most favorite function would be the function for the exponent, which is derivative of e raised to x is equal to e raised to x as well. Kaya lang dx, no? So, huwag natin kakalimutan yung dx. Kasi, kapag ito, halimbawa, derivative of e raised to 2x. So, copy lang yon, e raised to 2x, derivative of 2x. And what's the derivative of 2x? 2. So therefore, the answer is 2 e raised to 2x. Alright? So may ganung mga ruling tayo. So dito ganun din. So walang pinagkaiba. And then this is a more general power formula. A raised to x. A is any constant. So the answer is ln of A times A raised to x. Then we get the integral of A raised to x. Now since ln of A is a constant, this would be 1 all over ln of A times A raised to x plus c. Alright? And then we have the logarithmic function, ln of x is equal to 1 over x, the derivative. The integral of 1 over x is ln of x plus c. Alright? So this is on page, ayan. Page 282, no? So take note of the table. So anyway, it's there on the module that we have uploaded. All right. So we have example 2 here. Integral of 3x dx. Of course, we could get rid of the constant outside the integration. what remains is the variable x, and apply the power formula that says x raised to n, integral of x raised to n is equal to x raised to n plus 1 all over n plus 1. So for this case, n is equal to 1, n plus 1 is 2 all over 2. Then you just copy the constant plus c. Ayan. So ito yung mga pattern as provided by Larson and Edwards, the author of our book. So the original integral we may rewrite perhaps when we rewrite the expression, pwede natin palabasin na yung constant para mag-focus lang tayo sa variable. And then after rewriting, you integrate and afterwards simplify. Alright? So yan, isa pa sa mga rinire-write natin yung fractional exponent or the exponent in a fraction, particular denominator. It's better to rewrite it, expressing it into a numerator with a negative exponent. For instance, integral of 1 over x cubed could be written as integral of x raised to negative 3. Or perhaps a radical, integral of square root of x, it's better rewriting it to x raised to 1/2 as well. And then for this next example, so pag in-integrate, no? So this is one of the basis of your table, no? Diyan sa 5.1. So another constant, tanggalin ang constant, ilagay sa labas, just focus on the variable, and then integral of sine of x is cosine, negative cosine of x. Alright? So ganun din sa letter D. We could get rid of the constant. Kasi minsan ang problema, hindi na ilalabas si constant. Mali yun. That nakalabas siya. So here is 3 integral of 1 over x. Of course, ln of x. So absolute value yun. Okay, they have some clarification, Gillian. So I suppose there are samples here. I think the samples are clear for us. Now, when integrating polynomial, you just have one constant. No, one integral constant only. Now, of course, there are many terms and you could derive constants from that. You just integrate it into c. Ayan, katulad nito, integral of x plus 2. Now, you could separate the integration. However, we produce two constant, integrate na natin yun. No? Integrate na natin yung constants. C sub 1 plus C sub 2 is equal to C. Okay, another one. Okay, another one here. So this one. Siguro familiar ka na sa power formula, no?
Yes po.
Okay, so yan. So yan, yung mga constant yan, ilalabas lang natin, apply the power formula, x to the fourth, integral of x to the fourth, x raised to 5 over 5. Constant negative 5, labas lang. Yung x squared, integral of x squared, x cubed over 3. And then plus constant. And then if there's simplification, so far wala nang simplification doon. Okay, this is another rewriting the no? So example number 5 here is pertaining to a radical. Perhaps I could demonstrate using your octave. Yan. Okay. So here's the solution. Perhaps we could symbolic x, and then you have integral of, actually pag nag-octave or MATLAB, you don't need to rewrite, diretso na. Nagre-rewrite lang tayo for this type of computation, manual computation. So that mas mapapadali ang ano. Pero sa octave, you don't need. You just need to type the original you could just type the original the problem. Yan. Right? Yun ang sagot niya. Tingnan nga natin kung tama. So ito, may mga simplifications na ginamit dito. Simplifyin pa natin. Simplify. Simplify. Answer. Ayaw na. Kaya ayaw na. Make it pretty. Ayaw nga simplify, no? Ayaw nga ma-simplify. So anyway, so tingin ko pareho lang siya, no? Ang nangyari dito, in-extract mo yung square root of x. Factor na lang siguro, factor. Yun, no? Ayun, sakto. Ito na. Factor pala dapat ang sagot. So when we factor it out, lumabas yung 2 square root of x. Ang natira, x plus 3 all over 3. Sakto, no? Yun lang, hindi niya pinapakita yung plus c kasi symbolic siya. So here, inisa-isa, sinimplify. So we get rid of the radical in the denominator and express it into a single variable. So for here, x over square root of x is x raised to 1/2. 1 all over square root of x is x raised to negative 1/2. You do with the power formula. Okay? And if you simplify, you could simplify afterwards. Alright. Okay, rewriting before integrating. Okay, so for this case, lalo na when dealing with the integral of trigonometric expression or function, you need to recall your identities. Okay? Yan, we need to recall our identities. No, katulad dito, do pwede siyang ma-solve as is, no? No, kaya lang it's much better if we could rewrite it in such a way that it will be simplified, no? For this case, yung sine, in-isolate yung isang cosine so that become a tangent, then 1 over cosine is secant. Sakto, secant x tangent x, integral of which is secant x. Sige nga, try nga natin. Alright. Or integral. Integral of sine x all over cosine of x squared. So, dapat pala tatlo. Tapos, meron pa dun. Ayan. So, I think, okay. And what is 1 over cosine, Gillian? Secant, di ba? Hindi ko alam bakit ayaw nyo ma-simplify. Ayaw, no? Or paano kaya ito? Factor? Factor answer? Ganun na lang yun, eh, no? So, dapat ano kaya ito? So, okay din naman. No, si octave, eh, no? Ayaw niyang ilagay sa secant kasi naka-default sa in terms of cosine and sine yung sagot, eh. Alright, so what else? Palaking ko dito. Okay, so we need to rewrite, no? Yung mga yan, no? Rewriting, no? Pag radical, express it into a fractional exponent. And then of course, the constant needs to be get rid out of the integration process para hindi tedious yung solution. No? So these are example. I suppose you have seen that already. So we have here, no, a particular solution. Assuming we have, so depende yan sa corresponding values ng C, no? So various integers, no? So for instance, you have 3x squared minus 1. The integral is x cubed minus x plus C. Yan. But depending, no? So if you may have a particular solution, you may have intended to have a particular value of C. Okay, for instance, if this is the general solution, the initial condition, f of 2 is equal to 4. So this one curve that passes through 2 and 4, meaning this is a general equation or a general solution, but the specific requirement has an initial condition of passing through point 2 and 4. So it follows that f of 2 is equal to 4. By that, we could solve for the constant. And how will you do that? So we just substitute f of 2 here. F of 2 here. So we have, say we could substitute 2 here, 2 cubed minus 2 plus C. So that is 8 minus 2 is 6. 6C is equal to 4 because f of 2 is equal to 4. Na-gets mo, Gillian? So therefore, solving for C, so we have 6 plus C is equal to 4. Therefore, C is equal to 4 minus 6 or negative 2. So the particular solution based on the initial condition is x cubed minus x minus 2 kasi meron kang initial condition value. Alright? Makes sense, Gillian? So,
Yes,
mangyayari lang yung particular solution kapag may initial value condition ka. Pero hanggat wala, C will remain C. Unless otherwise, C will become solvable if there are initial value conditions. Okay, another. So, solution. Ayan, basta may initial value, kayang masolve. So, kung ang f of prime of x mo is e raised to x, and then we have a particular solution that has an initial condition of f of 0 is equal to 3. So, madali na yan, no? So, integral of e raised to x is equal to e raised to x plus c. However, f of 0 is equal to 3. Substitute x equal to 0. Then that will become e raised to 0 plus 3. Solving for c, it follows that c is equal to 2. For this particular case, we have e raised to x plus 2 as your particular solution. So yeah, meron pang mga ibang condition depending dun sa initial value condition. Okay, there are application now. I think we could go now to your exercises. Okay. Now just tell me your answer for even numbers, no? So you started at number 2.
Opo, sir. Bali hanggang 14 pa lang po. Ay, hanggang 12 pa lang po yung nasasagutan.
Sige, okay lang. Sige. Okay, pull down ko yung ano natin para makita ko rin yung okay, sige, can you just dictate your answer for number 2?
Ano po? 2x raised to 4 minus 1 over 2x plus c po.
Okay, correct. Okay, number 4.
Number 4 po, y is equals to 5t plus c.
Okay, correct. Number 6.
Y is equals to negative 1 over x squared plus c.
Number 6. Pakiulit ka din.
Y
Y.
is equals to negative 1 over x squared plus c po.
Okay, correct. Now, for the table, what's the first step of rewriting? Teka, pwede natin dito, abulin dito. Okay, for number 8, no? So what would be the given integral of 1 over
4x squared po.
dx. Okay, tama ba yung sinulat ko? So
Yes,
first, so what will be your rewrite expression?
Ano po? 1 over 4 tas integration sign po.
Okay.
Tapos x raised to negative 2 po.
So x raised to
Negative 2 po.
negative 2.
Dx.
Okay. Alright. And then, simplify, integrate.
Integrate po. 1 over 4 po. Tapos, parenthesis po ng x raised to negative 1 over negative 1 po.
Okay, good. Okay, simplify.
Negative 1 over 4. Negative 1 over 4x po. Plus c.
Okay, very good. Okay, sige. Then, kahit ano na lang. Sige, you just dictate the rewrite, integrate, and simplify.
Sa number 10, sir.
Yes, number 10.
Number 10 po, integrate 1 over 3x raised to 2 po.
Okay.
Times dx. Tapos, equals to 1 over 3 integration sign x raised to negative 2 po. Times dx.
May kulang.
Tapos,
take note, yung 3 na kasama sa squared. So, anong magiging constant ito? Diba?
1 over
3x quantity squared siya eh. So, when you distribute it, it will become 1 over 9x squared.
Opo. Kala mali ako.
Hindi, okay lang. And then, so ang rewrite mo dyan, 1 over 9, integral of x raised to negative 2. So, ayan.
Okay po, sir.
Okay, simplify mo na lang.
Ano po?
Yung integrate, yes.
Integrate po. 1 over 9, parentheses, x raised to negative 1 over negative 1 plus c po.
Okay, correct. Simplify.
Negative 1 over 9x plus c.
Okay. Sige, correct. Correct na yun. Pero yung yung 3, no, supposedly, yan, ingat ka, pati yung, kasi kasama din sa expression. Alright. Hanggang anong item ka na-solve?
12 po.
Sige, what's for number 12?
For number 12 po, yung rewrite niya po is 8 integration of x cubed dx minus 9 integration of x squared dx plus 4 integration of dx.
Okay. Sige, just the answer. Tell me the answer.
Answer po, 2x raised to 4 minus 3x cubed plus 4x plus c.
Okay. Sige, correct. Very good. Sige,
Nandun pa lang po siya.
Okay. Sige, walang problema yan. Siguro tuloy natin yung ano. Sige, we could particular equation, solution. Sige, sige. Sige, tuloy natin. So, for 12, siguro jump tayo sa can you try, sige, sige, 23. Can you try 23? Trigo function 12. Can you access the file?
Yes po, sir. Naka-open po.
Number 23. Yung 5 cosine x plus 4 sine x quantity dx.
Meron na po akong answers.
Sige, what's your answer?
5 sine x minus 4 cosine x plus c po.
Okay, correct. Huwag malilito dun sa plus minus ha. Maraming nagkakamali dyan. Ang naiisip, derivative in-apply sa integration, baliktad yung mangyari doon. Pag derivative of cosine, negative sign. Integral of sine, negative cosine. Yun dapat. Minsan maraming nalilito dyan. Okay, let me see. Yeah, another item. Sige, number 24.
20.
So, theta squared plus okay, that's the problem.
Answer po, sir, ano po?
Sige, go ahead.
Theta raised to 3 over 3 po. Plus
Okay.
tangent theta plus c.
Plus
Tangent theta po.
tangent
Plus c.
Kasi. Okay, correct. Okay, sige. Ibang application dito sa ako na to. Kasi ang normally, ang integration, more on area siya. Pero pwede rin siyang, it could be used for motion. Pwede rin siya, yung integration. Same as differentials. No? Pwede rin siyang gamitin. Now, on the latter portion, I have a slide here. I got this from Larson, mga professors to ni Larson, regarding yung susunod na topic natin about area. So, this is a concept of area. Ay, mali. I don't use that. Ang ginagawa ko dito, normally when I slide, hindi ko siya pinupull. Do you know this, Gillian? I normally use individual window.
Ay, hindi. Ngayon ko lang po yan right kasi.
Pag individual window kasi, buhay pa rin yung screen mo. Pag inano mo yan, tingnan mo. Yan lang. Kumpara dun sa no choice ka pag full screen. Wala na yung ibang portion. Hindi mo siya mako-customize. In fact, ito kaya mo i-customize pero naka-slideshow pa. Ayan,
Pwede po yan nga, sir, kapag sa congregational singing.
Oo.
I mean sa ano po, dito, sa preaching po, yung kapag yung preacher po walang binigay na slide. Yung susundan nyo lang, pwede po ba yan? Yung parang susundan nyo lang po yung preaching niya. Meron po kasing ganun Yung na-edit po habang naka-flash po
pwede
siya.
Siguro yun, pero hindi ko ginagawa yun Pwede yun, nakakita na ako ng ganun. Pero I don't do that. So ang point ko lang dito, para ma-customize mo yung ibang sections ng. Kasi ako normally, lalo na sa Sunday school ko, iba-iba yung may tatlo akong window Una yung Bible, tapos yung pangalawa yung lecture notes ko. Minsan yung camera ko sinasama ko. So tatlong window yun. Pag naka full screen ka, wala lahat yun, takip lahat yun. So yun yung isa yan sa way. Pero ito, makokontrol mo pa rin siya as if you are just presenting. Yun nga lang, hindi ka lang siya makapag-annotate. Unlike sa full screen, makapag-annotate ka So pwede ka mag-highlight. So, yun nga lang ang disadvantage. May pros and cons din siya. So yun So this is a presentation on the area. Sorry. So actually concept siya ng finite sums. Finite sums. Yung pinakita kong picture kanina sa'yo, yung about the integration. Yan, kasi we are actually summing up all of these slices, trapezoidal slices, that would cover the area of that particular curve, bounded by A and B. So yun yung ano natin dyan. Okay, so of course here, an example would be a moving object at a constant rate of 3 feet per second. And since the rate times time is equal to distance, so you have 3t. Okay, so there's an illustration here. So constant yun, since we are in a constant rate, regardless of the time bound, there is a constant velocity. Constant velocity. So iba kasi ang graph kapag ang velocity ay may acceleration. Iba yon. Now, I don't know if you recall in physics, when it is in acceleration, ano siya? Pag ganun, direct proportional. Ibig sabihin, velocity continuously varying with respect to time. But for this, regardless of the time, constant ang velocity. So that's constant velocity, no acceleration. Wala siyang acceleration kasi constant lang yung tuling niya. Hindi siya nagmamadali, hindi siya bumibilis. So yan, yun. So after 4 seconds, the object has gone 4 feet. So yan yung etc. Solving for distance. So this is just an illustration of a constant. If the velocity is not constant, perhaps acceleration, we might guess that the distance traveled is still equal to the area under the curve. So yan. So magkakaroon na tayo ng quadratic expression doon sa may varying velocity, or sometimes we call it constant acceleration or variable velocity. So from here, walang problema kasi dito eh. Kitang-kita yung sukat ng area, no? Tama? So 3 times 4 lang yan, 12 feet. Yun yung distance. Walang problema pag constant velocity. Ang nagiging problema kapag naging second degree equation na siya. So diyan mas nagiging komplikado. So normally, nahati natin siya. Ang tawag diyan ay left-hand rectangular approximation method. Wherein meron tayong mga nilalagay diyan na mga certain slices of the curve. For instance, at velocity equal to 1, time equal to 0. So yan, hinahati-hati natin siya. So nagkakaroon tayo ng approximation. Of course, we don't need to measure that anymore. This is just for graphical representation. So yan, time, another slice, no? So nagbabari siya with respect to time, and this is not constant. So we could just approximate the rectangle or the trapezoid. No? Kasi kaya siya naging trapezoid pag sinama mo yung triangle doon. Di ba? So trapezoid na siya eh. Hindi na siya, yung rectangular is just an approximation. Ngayon, kung papaliitin mo yung rectangle, yung papaliitin mo yung dx mo or yung change of x, no, saka siya mas magiging accurate. Mas pino yung t, the better, no? The more precise the area. Kasi pag mas malapad yung hati mo, katulad nito, meron siyang space na hindi na-cover. Just like this one. Yan. So, of course, we could just approximate the area. Pero, of course, meron pa tayong mga hindi na-cover dyan. Yan. Now, estimating with finite sum, so we could also use right-hand rectangular method. So, right-hand, yan, sinobrahan niya naman. Pansin mo, sobra, no? Kanina, kulang. Kulang, di ba? Ngayon naman, right hand. Pag sinabing right hand, nagsisimula ang measurement mo sa kanan papunta sa kaliwa. So, ibig sabihin yung point dito, yan ay i-consider mo ba pakaliwa. Yung kanina, mula kaliwa pa kanan. Kaya meron kang space doon. Kasi nagsimula sa kaliwa pa kanan. Kaliwa pa kanan. So, yung varying. Sa right-hand rule naman, baliktad ang nangyari. Ayan. So, therefore, the approximate area is 7.75. Now, of course, we could have the mid-rectangular approximation method. Ito naman, yung gitna talaga. Medyo tedious to. Yung gitna. Ayan, no? So, very tedious yan. So, kung ano yung madatnan ng gitna ng triangle, yun ang susukatin niya. Alright? So, ito. So, in this example, there are 4 subintervals. As the number of subintervals increases, so does the accuracy. So, yung interval o yung distance ng dx mo, yung change of x mo. Kasi yung change of x, mag-aano yan eh. Tawag doon, mag-approach ng dx yan. Sooner or later. This one, approximate area is, so this is somewhat in between the left hand and the right hand. Kanina, 5 point, may recall yung kanina. Ito, yung right hand, 7.75. And then yung 5.75 naman yung left hand method. So we will expect for the middle ay, we will be expecting somewhat in between 5.75 and 7.75. Which is, ano nga ba yung area niya? 6.625. Yan. Now, this is with 4 intervals. What if you will do the 8 intervals, no? Pinapaiksi mo yung change of x mo. No? Sa halip na 4, naging 8. Yan. Naging 8 na siya. So, ano yung kanyang, ano, no? So of course, with the width of sub-interval, we will multiply to 0.5 kasi hinati mo sa dalawa. So, yan. Still 6.65. Right? Approximate area. The exact answer of the problem is 6.6, continuing 6. No? Approaching na siya. Malapit na siya. No? Kasi pag linitan pa natin yan, we'll be approaching that particular sige nga, pwede nga natin computing to pala, no? Pwede natin computing to. 1 to 4 eh. 0 to 4 siya, no? So, integral of 1 over 8 times x squared plus 1. So, yung px, no? So, comma, from 0 to 4. Ano, tama yung coding ko dito. Yan, para makita rin, ma-verify din natin using Octave. Yun, may hindi nakasim. Teka, nakalimutan niya yung symbolic kanina. Since x. Nakakalimot kasi ito si Octave eh. Kasi pag nag-offline siya, putol lahat ng variable mo. So, ulit ka ulit. Buti na lang, pero yung command, you could just press up and down button, marirecall niya. Yun, no? 20 over 3, which is equal to 6.66, no? Tama?
Yes, sir.
So, ay, dapat pala palakpak kasi tumama tayo. So, ganun siya. 20 over 3, tama? 6.66. So, yan. So, kung integrate mo siya, yung area na yon na kinumpute mo, mag-a-approach na 6.6. Infinite 6. No? So, ganun natin, that's how we define geometrically in terms of a finite sum. Finite siya kasi meron siyang hangganan, no? From 0 to 4. No? From 0 to 4. Pero, ang infinite dito, yung slice o yung interval. No? It could approach infinity. No? Kasi yung width naman, nagbabari eh. Habang dumadami yung interval mo, lumiliit yung width mo. Oh, can you try to imagine that? So, possible ang infinite numbers of interval. Palagay mo. O meron pa rin siyang finality. Palagay mo. Kasi yung pinakamaliit na maiisip mo, pwede mo pang hatiin uli yun. Tama ba? Kunyari, pinakamaliit sa'yo, 128 parts. O pwede kong isipin, pwede pang gawin 256 yan eh. So, hindi matatapos yung argument na yun. Infinite number siya of intervals. Ganon ang integration. Ganon ang concept niya. So yan, inscribed rectangle are below the curve. Yan. So, estimating to. So this is more of a left-hand method, no? Left-hand method. Circumscribe naman, ito naman yung right-hand method kanina. No? Right pa kaliwa, kaya lumagpas. So ganon. We'll be learning how to find the exact area under the curve if we have the equation of the curve. Rectangular approximation method are still useful in finding the area under the curve if we do not have the equation. Kung wala tayong equation, we could measure. Pero kung meron tayong equation, we could make use of our integration na formula. No? Katulad ng ginawa natin dito sa Octave. Ayan. So we find the area under the curve by adding rectangles. That's what we call Riemann sum. Yun yung adding these rectangles is actually adding the area of the rectangles. Is what we call Riemann sums. Or sometimes we call it magiging definite integral na siya kasi katulad ditong sinolve natin, 20/3, is a definite integral. This is a definite area presentation. A definite area of a curve, of a known curve. No, kung yun nga, kung we could still use approximation of integration if we don't know the equation. If we don't know. But if we know, make use of the integration. So with the rectangle is the sub-interval. Yan, mga sub-interval yan. And the entire interval is the partition. So yung partition mo, that's your lower and upper limit. No? Yung ginamit natin kanina dito, lower and upper limit yan. So from 0 to 4. So the equation, 1 over 8x squared plus 1, integrate from 0 to 4. So that's your partition. Yan. Sub-intervals do not all have the same size, yung sub-interval. So, of course, depende yan eh. So, the smaller the size, the more accurate is the identification of area reaching to the actual area. No? So, yun nga, sabi siya, mas palit ng papino yan, mas nagiging accurate siya. Kasi nga, yung error niya, yung degree of error, nababawasan din. Katulad nito, yung mga rectangle dyan, or triangle, these are degrees of error based on approximation. Ayan. So if the partition is denote P, then the length of the longest sub-interval is called the norm. Yan yung norm of P. And is denoted as this by absolute value for symbol. As P gets smaller, approximation gets better. Okay? So, yun yung in-explain ko rin kanina. Okay, that's why we have the area, and this is now the definition of integration based on Riemann sum. It's the summation in the limit such that the norm should be approaching zero. Hanggang parang yung change of x mo maging zero na. No? No, kasi it will have an infinite number of interval. No, or sub-interval pala kasi yung interval mo yung dulo-dulo lang. No? Ayan, no? So this would be the formula. So ito yung change of x of k, ito yun eh. Ito yung difference, no? Tapos yung f of ck mo, ito yung value at a particular level. So para kang in effect, you are actually solving the area of the rectangle or the trapezoid. So yun. And then ang ano niyan, as P approaches zero. So ibig sabihin halos wala na. Halos wala nang width. Pero hindi pwedeng maging zero kasi pag naging zero, walang width yun. And of course, 0 plus times something is equal to Kilian. 0 times something is equal to
Zero po.
0, di ba? So walang area. Kaya hindi siya pwedeng mag-equal kay 0. Approaching 0 lang based on the formula. Ayan, no? Oh, limits, di ba? Approaching lang siya. Of course, at k is equal to 1 up to n, depende kung saang ilang slice yan. Kung ilang hati ba yan. Na, kung hati mo, 100, di k2 is equal to 1 up to 100 yan. So therefore, meron kang delta x 1 up to delta x sub 100. Ganon din yung counterpart niya ng ck. F of c sub 1 up to f of c sub 10 o sub 100. Yung corresponding values niya sa y-axis naman. So yun. And P is the partition of the interval KB. And then of course, theoretically, there are infinite number of sub-interval. Alright? Now, this particular definition is called the definite integral. Ito na yung definite integral kasi meron tayong interval of AB, which is actually your lower and upper limit. No, F over AB. So yan. So we use a sub-intervals of an equal length. Then the length of sub-intervals is actually the change of x is equal to b minus a all over n. So that's the formula of the change of x. Depende doon sa number of n or intervals mo, sub-intervals. So this has an equal length. So ibig sabihin, kung yung upper limit mo b minus a, yun yung lapad mo, yung haba mo, hahatiin mo ngayon doon sa ilang interval, sub-interval. And that would be the value of your change of x. Okay? Parang nagre-review tayo ng analytic, no? Ano? Kilian? So, the definite integral is given by this formula. Yan. So, kung ang pagbabatayan naman natin interval, then yung nag-switch So, kanina, yung width. Yung norm, yung width ng interval. Ngayon, nag-switch tayo doon sa number of interval. Pag ang number interval naman ay mag-approach ng infinity, yun, mas pasok to. No, kasi we don't know the number of interval, sub-interval, no? And it will approach infinity. Kasi yung whenever you think of something, I could still think of a smaller value than what you're thinking. For instance, I would divide the interval AB to 256 sub-intervals. I could still think of 512 and you could still think of 1024 and me 2048, etc. etc. Walang katapusan yon. Walang katapusang hatian. So theoretically, it's approaching infinity as well. So pareho lang itong formula na to, kung tutusin. Pareho lang siya. Pero kung equal, kung equal length naman siya, pwede na natin siyang masimplify. No? Kaya dito, change of x na lang kasi equal length na siya. No? Equal length na siya dito. And then yung ck mo, f of ck, yun pa rin yung corresponding values ng y. Alright? So, okay ba? You have some clarification?
Wala naman.
Pero may parallel sa area discussion Yes.
Opo. Okay, sir.
Nandun sa area, iba lang yung banat nito eh. Pero yun pa rin yun.
Okay.
Of course, it's the bits that introduce. Medyo may kaibahan lang ng konti yung kaya. Pero halos they're talking of the same thing.
Yes. Sabihin ko na lang.
Okay. Dali lang meron. May mga minomonitor ako dito mga YouTube channel. And it's all around me. Alright, anyway. So this Leibniz introduced a simpler notation for this. Dito, dati ganito ang integration o antiderivative, ganito ang expression. Pero parang hindi nila magets. No? Kaya sinimplify ni Leibniz yan. Ayan. Dati, prior to Leibniz, yun, limit of summation, no? Matindi, no? Kasi nga, hindi mo alam yung actual expression eh. So it's just measuring entirely the area, one at a time. No? So, but this could be simplified further into an integral formula, a to b, which is the function of x, dx. So, yan na ngayon yung modern integral or antiderivative. Okay? So, yan yung natin. So, more on history lang to. Though that the very small change of x becomes d of x. So, yan na yung d of x. Yung maliit na distansya na yun. Right? So we have here the symbol of integration and the lower limit. Of course, b is the upper limit. And the integrand, of course, and the differentiable variable or variable of integration or the dummy variable. I don't know. Si author lang ang may nito bakit kaya dummy variable. Mahalaga yung dx kasi aalamin mo kasi alimbawa kung maraming variable dyan, hindi mo alam kung anong iti-treat mo as constant or variable. So it's dx or the one that will be putted on that dummy variable will determine whether is the one that is integrable or not. For instance, dx, ang integrate natin yung x. Kasi iti-treat natin yung y as constant. Ganun siya. Ganun yun. It's called dummy because the answer does not depend on the variable chosen. Ayan. So anyway. So we have a notation for integration but we still need to learn to evaluate integral. So of course, we will be doing that. Actually, we're doing it already. So area under the curve as a definite integral, y is equal to f of x is a non-negative integrable over closed interval AB. So there is this definite value for a and b. Then the area under the curve y is equal to f of x from a to b is the integral of the function of x from a to b. So parang kinukumpute mo rin dyan yung area. Yung area. Bounded or area under the curve. Okay? So, parang ano na, no? Tapos na ba? Ayun. Okay. Iba pala. Sorry. Parang nalito ako dun. Bumalik tayo dun sa kanina. Okay, so this one, of course, this is a constant velocity, no? If the velocity varies, ito naman constant acceleration. So with the velocity varies with respect to time in constant acceleration. So distance of the curve, distance is under the curve. No? So normally, ayan, 1/2 t plus 1. So of course, we could compute for the area bounded by the curve. So by integration. No? So from 0 to 4 na naman siya. So pwede natin masolve to. Integral of x over 2 plus 1 from 0 to 4. Yan, 8. Pero kung by inspection, pwede natin masolve to eh. Kasi ito, so 4 na siya, no? 4 times 1 is 4. Yung natira is 4 times 2 divided by 1/2 kasi rectangle lang, no? So 4 times 2 is 8 over 2 is 4. 4 plus 4. 8, no? Tama, no? 8. So pwede natin talagang masolve siya kahit wala yung equation. No? So yun lang, mahirap lang talaga kung isa-isahin mo. So we have here the trapezoidal rule. Yan. Dito na papasok yung trapezoid, no? Okay, for here, so 1/2 your height, base, yeah, of course. So you have 1/2 height times base 1, base 2. So 1 plus 3. But parang 1 plus 2 yun. Anyway. So ano ba yung ginawa nilang height dito? Medyo na-weirdohan ako. No? So anyway. So parang binaliktad nila eh. No? So tinabingi nila, Gillian, pansin mo, yung trapezoid, tinayong ganun. Kaya naging height niya is 4. Tapos yung base 1 is 1 at yung base 2 ay 3. Na nakuha mo, Gillian. Tinayong ganun, no? So, di ba nakaigang ganyan yung trapezoid? Tinayong ganun.
Sir. Yes po, nakakuha ko po. Opo.
Yes, a trapezoidal rule. So of course, these are our formula. This is also equal to the modern integration formula. And this is equal to f of x minus f of a. Now, we'll see, no? Parang dapat f of b to. Mali siguro to. F of b dapat to. Yung f of b dapat. Mali siya, no? Palagay mo. So, nagkakamali din, no? Logically, kasi in-integrate mo na, meron ka ng definite integral doon. Yung f of x mo ngayon, definitely this is equal to f of x, yung capital. Evaluated from a to b. So therefore, f of b minus f of a.
Opo. F of b, opo.
Nagkamali siya doon. So, yan. At least lamang na tayo sa mga hindi lang tayo. Nagkamali siya. No, kasi nakapost sa website ng professor to eh. So dapat siguro may nag-comment din. So where f of x is the antiderivative. No? So we know that already. So from here, ganun din yung ginawa natin kanina. Na-solve na natin yung area nito. This time, you will be using trapezoidal rule. This time, multiple trapezoid. Yeah, multiple trapezoids yung ginawa niya. It seems reasonable that the distance is equal to the area of the curve. Yan. So, tama, no? 20/3 kanina tayo, no? 20/3 yung solution natin dito. Eh. So, ganun din yung ginawa niya, integration. Ayan, 6 2/3 or 6.66, etc. We can use antiderivative to find the area under the curve. Katulad dito, so we have a definite value for x from 0 to 2. Okay, can you compute the area? Using integral of x squared when evaluated from 0 to 2.
0, wait lang. Walang scratch.
Okay.
So, 3. 0 to 2. Four. 8/3 po, sir. Ay.
8/3. Okay,
Oh,
let's try. Tingnan natin dito. So, x squared from 0 to 2. Yan, 8/3, correct? 8/3. So, ang area. Pero minsan, ganito ang tanong tricky. What is the area over the curve? O, di ba? Ayan, tricky yun. Kasi ang sinod natin dito, area under the curve. It's always area under the curve. So, kaya mag-ingat ka sa ganung mga honestly sa let exam bihira yung calculus problem. Bihira siya. At least based on my experience, no. So there are few, yun lang, mag-iingat lang tayo kasi baka yun na yung supposedly tamang sagot, mamamali pa dahil nakalimot ka sa calculus. So dapat wala nang palampasing mga items eh. No, though honestly, konti siya. Siguro hindi tataas ng 10% lang. Hanggang 10% lang ang itatanong sa calculus. Pareho na yun, differential integral. So, pero hindi pa rin siya... hindi, 1 to 2 pala. Ang tanong, mali tayo. Hindi ko kasi inano yung slide eh. Sige, compute mo ulit, 1 to 2. Hindi pala 0 to 2. 1 to 2 pala. Recompute ko rin dito.
7/3 po.
7/3
po.
3. 7/3. O ano, sige. Tingnan natin. Okay, so yan. So 1/2. So of course, ito yung procedure natin. We have the power formula, of course. Then yan, 8/3 minus 1/3. So we have the area from x. X equal to 0 and x equal to 2. Hindi, x equal to 1 yun. Ano ba talaga? Niloko ko nito.
Ayun po.
Ano lang, kasi x to 0 lang eh. X is equal to 1 up to x is equal to 2. Kasi yun yung tanong niya, wala naman 0, diba? Anyway. Yan. Area from x. Okay, makes sense.
Parang
from
ano lang po.
0, parang yung buo. Tapos yung area. Okay, nagets ko na. So yung buo muna. Tapos sinubtract mo yung from x raised to 0 up to x raised to 1. So mga iiwan, yung between 1 and 2. Tama. May point. 7/3, correct. Ayan, kahit pa paano. At least meron tayong octave. Baka ginugoyo tayo ng slide. At least ito, may matibay tayong sandatan. Okay, so find the area of... karamihan sa mga American University, meron silang Texas Instrument Calculator. Normally, ang sikat doon, Texas Instrument o yung TI calculators. Sa atin, Casio, di ba? Or Sharp, gano'n. Ano bang ginagamit mong calculator?
Casio po.
Casio?
Yung...
Pag mag-board ka na, check mo yung mga listahan ng pwede sa board, ah.
Meron yes,
bawal, eh. Meron kasing bawal. So, sayang kung bibili ka ng hindi pwede. So, may listahan sila. You just download it from the PRC website. Ano yung mga pwedeng gamitin calculator. Normally, non-programmable. Non-programmable scientific calculators are allowed. Okay, so sa Amerika, normally, gumagamit sila ng Texas TI-83. It's a graphical calculator. So, napakalaki ng screen ito. Ayan. Sige nga, kindly compute. This time naman, area between x-axis and y-axis. Y is equal to cosine x from 0 to 3 pi over 2. Ayan, may region measurement na tayo. So from 0 to 3 pi over 2. So yan, dapat ano rin, yung equivalency ng region sa degrees, huwag mo kakalimutan yan. Built-in yan sa isang math professor, math teacher. Hindi dapat tayo nalilito sa mga angular measurement ng region sa degrees. At least. Ano yung 3 pi halves? Anong ilang degrees yun? Ganyan.
Alin po yun, sir?
Ilang degrees yung 2 pi regions? 2 pi over 2. 3 pi halves regions. Ilang degrees yun?
Ano po? 270 po.
270, correct. Huwag ka malilito dyan ha, kasi kada pi, 180, tatandaan mo yan. Kada pi, 180. So, meron ka ng isang pi dyan, plus 1 ha pa. Ano yung kalahati ng pi? 90. So, 180 plus 90, 270. Okay? So, yan ang wag mo kakalimutan. 1 pi radian is equal to 180 degrees. Isang straight yun. Straight. Kaya yung buong bilog, dalawang straight yun. 2 pi. Kaya siya 2 pi. Yung 1360. Okay? Do you have the answer? May kumpitin din natin dito. Hindi ko alam kung rods ang default nito. Malalaman natin sa sagot mamaya. Sayang ng Friday, mahina yung connection ko sa opisina eh. Nasa office, nakita ng konti eh. Nauna ka sa akin mag-login eh. Yung Biyernes. Kaya lang, mahina yung ano. Ay, nung nagre-reconnect na, wala na. Nako, ayoko nang paghintayin si Gillian. Kaya ngayon lang week na to tayo mag-meet ng twice. No? Pero next week, Wednesday na tayo. Wednesday tayo. Yung Friday kasi medyo na kompromiso ako eh.
Ang dami po bigla.
Pangatlong subject ko. Na nag-2 hours. Halos 4.5 hours na ako magtuturo. Tapos sa'yo, na 3 hours pa. So medyo ano yun, medyo mabagsik ng konti schedule. Kaya iuurong na lang kita ng Miyerkules. So, I'm limiting myself to 2 subjects per day lang sa supposing.
Sir, -1.
-1. Okay.
Pag naka-region po.
Tingnan natin. Pero mas tingin ko tama ka, negative siya. Kasi nga, from 0 to 3 pi halves, ang cosine 0 kasi 1 degree, no? Ay 1, tama. Cosine 0 is 1.
Opo.
So mag-neutralize siya dito eh. Tapos meron ka pang kalahati. So maaaring tama. Let's see. Ayun, -1 na. Tama. Okay, rods pala tong octave, no? Rods.
Opo.
So dito pa lang visually, yung dalawang kalahati. Ayan. So ito pala, -1 lang pala to. -1 pala yung at least medyo graphically na ano ko. Kasi mag-neutralize lang tong positive saka negative na kalahati. Tapos ang matitira may kalahati. Okay? Anyway, so this is how they do it. Alright, so meron pa siyang ginawang strategy dito. Kasi ang ano, so positive nga naman yung 0 to pi over 2, sinubtract niya ngayon. Mukhang mali tayo ah. Tingnan natin. O positive, negative, di ba? Oh, tama, negative. Negative ang lalabas, no? Meron pa siyang ganong interval. Kasi sa positive interval, 0 to pi over 2, positive yun. Ba't minus niya? Kasi negative area. Kaya minus, no? Imbes na positive, negative area siya from pi halves to 3 pi halves. Ayan. So, pero pwede naman diretso. Pwede. Medyo komplikado lang yung ginawa ng mga kanungton. Ayan. So, 1 minus 0. 3 ang sagot. Oh, tama siya, tama. Kasi yung area naman, yung area, whether it's a negative positive, won't cancel because still an area occupied. Hindi siya magka-cancel. Tama ang ginawa niya, may preparation. Kinumbay niya lang muna yung kinumbay niya lang muna yung positive area, then minus the negative area. Tama. Pero tama rin yung ginawa natin, yun lang. Dapat pala pag-iwalayin kasi pag negative 1, ang nangyari doon sa ginawa natin, pinagsama natin yung dalawa. Plus siya. Negative to, kaya matitira isang portion, negative 1. Samantalang kung bibilangin natin siya, 1, 2, 3. No? Yung kabuuang area, positive 3 siya. Anyway, area is always positive nga pala. Di ba? Well, there's no such thing as negative area. Alang namang tanungin ka, ilang area ng bahay mo? Negative 50 square meters. Walang ganon. So, it's always positive ang area. So, mali tayo. Naka 1-all na tayo. Kano, 1-all na tayo. Kanina, may mali rin kayo. Ayan. So, at least we're learning from this, no? So ang ginawa niya para hindi ma-subtract, hindi magkaroon ng subtraction dun sa area, treat niya as negative area yung mga portions under the negative area, which is pi over 2 up to 3 pi halves. Nagets mo na yan? So ako, natutunan ako. Alain mo, may ganun palang Pero tama siya. Wala nga naman palang negative area. There's no such thing. Nako, mali na sana tayo kung lumabas sa board exam yun. At least, natutunan natin dito. Tama, kasi dapat talagang hatiin, no? Kasi magkaiba yung area. So, all negative area corresponds to negative sign. All positive area correspond to a positive sign. Just like this one. Alright. Okay, thank you, sir. Yan, definite integrals, antiderivatives, no? So, huwag mo lang pansin yung page number niyan. So, meron din ako, actually may libro din ako niyan. That is, hindi kasi Larson yan eh. That's, may ibang author. Stewart. Stewart yung author ng though ginagamit ko rin siya paminsan-minsan. Pinagpapalit ko siya. Actually, last time Stewart gamit ko eh, pero bumalik lang ako sa Larson ngayon. Anyway. So, ito. So, isa sa mga properties ng antiderivatives and definite, yung pag-change ng sign. Pag reverse mo yung upper and lower limit, it will have a negative area implication. Ayan, negative yung integral. No? So, pag reverse mo yung A to B, ginawa mong B to A, it will have a negative. Negative implication. So, reversing the limits changes the sign. Number 2, the upper lower limit are equal, definitely the integral is 0. Kasi, wala kang difference. Difference ng from point A to point A, 0.
Wala.
Ayan, 0 siya. So, tama, no? What else? Okay, constant multiples can be moved outside. Ayan. Pareho lang siya. Even for antiderivative, which is indefinite integral, apply din siya sa definite integral. Okay? And then, of course, yung integrals, no, that could be distributed in terms of addition and subtraction operation still applies to integration and differentiation. So, yan. Parang, reinforcement na lang to ng kanina. Ayan. intervals can be added or subtracted. No? So depending on the position of the area, whether it's positive area or negative area, just like what the previous problem that we have. No? So pwede yung from A to B and B to C, pwede siyang ang sum nilang dalawa A to C. Pero nangyari kanina, A to B minus B to C. Bakit minus? Kasi negative area.
Nasa ilalim.
Ayan, katulad nito. Ayan. So, pareho sila. Additional yan kasi parehong sense yung direction ng area eh. Parehong positive ang sense. Oh. Ayun naman, ito, teka. Oops. So, may minimum maximum siya, no? So isa sa property niya rin, kapag sinubstitute mo yung integral nito, it could be less than equal the minimum value of ang symbol na to, yung integral na, yung f of b minus a, minimum value. Ito naman f of b minus a, maximum value. So parang hindi na, so parang ano na natin yan, hindi na natin parang this is more on ano na lang eh, geometrical presentation. Okay, suppose f and g are continuous function. Yan. So, binigay yung sagot. Definite area, oh. Oh, binigay yung sagot. So, paano natin siya suppose f and g are continuous function and that. So, yan, may mga interval dito, no? Ayan, so dapat ma-define yung function. First and foremost, we must define the function. Kung hindi mananatiling hindi natin sagot yan. Acknowledging Ma'am Tess MB, salamat po Ma'am Tess. Thank you for dropping by. Siya po yung nasa YouTube natin. Ayan. Tingnan natin kung may sagot. Uy, 3. Alright. 0. Of course, 0 yung property. No? Okay, so paano nangyari yun? So given, analyze natin yung bawat given. No? So ito yung mga given. I think isang bulto lang ng ano lang to, ng given, and then all question related to any of the three. So kung yung f of x mo from 4 to 2, meron kang 2 to 4 eh. So reverse. Tama? Reverse property. So kaya 3 yung sagot dito kasi given na yung 2 to 4 is negative 3. Ayan. How about negative 2 to 2? So meron kang factor of 2 diyan. 2 times 5 is 10. Tama nga naman. And then you have 4 to negative 2. So meron kang ano diyan, meron kang negative 2 to 2 which is reverse. Pag reverse mo yan is negative 5. And then meron kang
ito pong nasa un. Yung kanina.
Etong 3, 2 to 4. Tas negative so kasi ang pwede nating split to sa 4 to 2 tapos 2 to negative 2. Dalawa, no? Ulit, 4 to 2, 4 to 2 to 4. Parang 4 to 2. 4 to 2 siya. Kaya meron kang given 2 to 4, so positive 3. Positive 3. Tama? Ano yung matitira? Kasi ang interval mo dyan, 4 to 2, 2 to negative 2.
2.
4 to 2, meron kang 2 to 4, positive 3. And then 2 to negative 2, baliktad pa rin, kaya negative 5. So, ang effect, negative 5 minus negative 3. O, kasi negative 3 yung given, positive 3 na siya. Bali maging negative 5 plus 3 is equal to 2. Okay, medyo nakakalito lang. No? O, yung negative 2 to 4 naman, negative 2 to 2 muna is 5. And then 2 to 4, it's negative 3. So 5 plus negative 3 is 2. And of course, yung 3 to 3, 0 yan. And then meron kang mga ano dito, 2 to 4, may negative 3 times 3 minus 2h, x is 6 yan. So, ayan, negative 9 minus 12 is negative 21. Okay? Medyo challenging siya. So, average value. Yan. The average value of a function is the value that would give the same area if the function was a constant. So, that would be the case from 0 to 3. Yan. I-check nga natin to. Yan, 9 halves. Or 4.5. Now, the average value per interval, now because we assume 3 intervals here from 0 to 1, 1 to 2, 3 to 4, at an average, so pag represent mo siya as a rectangular area, instead of following the shape of this, so it could be an average of 3 rectangles that has 1.5 area each. So, ganun yung mangyayari. Yun yung implication ng average value. No, halimbawa, 3, hinati mo sa 3, yung 4.5, tagwa 1.5 na puro rectangular. Okay? So, pero pareho pa rin siya, 4.5 pa rin siya. Ayan, no? So, yung 1.5 mo, katumbas lang siya dun sa 3. Halimbawa, 3 siya, hinati mo. Ayan, so ganung klase lang yung ano. Okay? So, parehong area lang siya. Now, the average value, area over width. So, it will be B minus A. So, B minus A is 3 minus 0. So, 3 minus 0 is 3. Kaya yung, kung ano man yung sagot dito, 4.5 over 3. Now, that becomes 1.5. Okay, 1.5. So, depende yan doon sa area over width. Yung area mo is 1, no? Now, theoretically, all of the area is treated as 1 per function, but over width, that is dependent on the upper and lower limit. This time is 3 minus 0, so 3, multiplied by, so meaning, yung kabuuan, hahatiin mo sa 3 bahagi. No? So, based doon sa 3 minus 0, and then times 4.5, which is the area, so 1.5 is the average value. Okay, average value. For what values in the interval does the function assume an average value? Alright, so ayan, yun yung mga ano. So, of course, this portion, so pag binaliktad mo siya, binalik mo yung x squared, 1/2, x squared is equal to 3, or x is equal to plus minus square root of 3. 1.5. So, either of the 3 values could be fitted on the average value, which is 1.5. No, para kang gumawa ng linya, 1.5, yung area under it, that's the equivalent of the entire area under the curve, which is 1/2 x squared. So either on these 3 equations, pare-pareho lang to, tatlo equation na to. Okay, the mean value theorem for Debye integral says that a continuous function at some point of an interval, the actual value will equal the average value. Yan. So, continuous, no? If f is continuous on A and B, then at some point C, no, C is at AB. So, C is any point from between A to B. So, meaning, kung may particular point na kung saan yung average value, katulad nung kanina, no? Ito yung f of c mo dun sa point na yon. Sa point na yan, yung f of c, yan yung average value mo. Pero nag-intersect siya dun sa curve. It's along the curve, that f of c. That's a value between A and B, point A and B, or between 0 and 3. So in this case, 1.5. Sa value 1.5 along the curve, that's your f of c. At yung tukoy dito. Yan, f of c. At some point in A to C. Yan. Find the total area bounded by x-axis in the graph. Y is equal to x squared minus 3 from 0 to 4. Ayun na naman tayo, may negative na naman. Let's be careful now. From 0 to 3, negative siya. Kaya magkakaroon tayo ng negative value doon, no? And then magiging positive siya pagdating ng 3 to 4. Okay ba?
Opo.
Sige, kindly solve the area. At least meron na tayong dapat palang area palaging positive. Yun ang nakakalimutan ko rin. Sige, kindly solve. So ako naman, gagamitan ko rin ng to. So dalawa yung magiging negative. Papasimulan ko ng negative integral of x squared minus 3x. From 0 to 3 lang siya. And plus, magpa-plus ako, integral of same function, minus 3 from 3 to 4. Oh, my child. With mommy. Sige, ikaw muna. Solve mo muna. Gillian. Don't stamp your feet, anak. Sadie Wood, Edri. Magigising si Sadie, anak. Edri.
Can you please stop laughing at me? I'm trying to dance.
Okay, acknowledging Jasmine Gracia. Ilocanang Inday. Thank you for your thumbs up grade, mga Ilocanang Inday. Madam, thank you Thank you for welcome to my calculus class. Baka sinong gustong sumama. Ayan, thank you guys for dropping by. Lahat ng Ilocanang Inday team dyan sa ating live stream. Yan, binisita tayo sa ating yan. Ngayon lang naning may team amo din. Ang dami pala. Yan, sample. Ito mga messages nila. Ayan, thumbs up done from Ilocano. Kasi they're actually visiting for support. Parang ganun. Mga friends ko rin to mga pupunta dito. Oh, thank you John Carl for loving math. And this is actually calculus. Thank you John. Ayan, mga math majors kami. Kaya magkakasundo tayo, Brad. Ayan, salamat din sa kay Preni, no? Yung Preni Chips, yung team ni Preni Chips. Salamat sa iyo, Madam Mouse and Kiss. Ayan, and yung Team Ilocana. Thank you lahat ng Team Ilocana diyan. Ayan, welcome to my calculus class. You could stay if you want. Ayan. Okay, Gillian, you have the answer.
Sige lang mag. Yeah, wait lang po. 4. 183.
1.83. Tingnan natin.
Sana tama po.
Parang malaki. Sige,
Wait
tingnan
lang.
natin yung slide. 83.6 eh.
Wait lang po. May nakalimutan na. Negative 4.5.
Negative yung dulo. So, nagsimula ka dun sa negative sign. Kasi negative area yung from 0 to 3.
Opo. Wala. Bali, sir, yung 0 to 3 po, di ba po negative po yung sign nun?
Oh, yes.
Tapos yung kabila po, positive na po siya.
Positive na. From 3 to 4. Positive area na siya.
8/3 po. Tama ba?
8/3. Ba't kaya
Sige.
86/3? 83/6 ako. Baka ako mali. Let me see yung ano ko. X squared minus 3 lang. Times, mali ako. Ako pali mali. Kulang ako ng 3x doon. X squared minus 3x. No? Tingnan natin kung magbabago. 19/3. Anong sagot mo?
Ano? 8/3 po.
8/3. Sige, tingnan natin. Tingnan natin. Ayan. O, tama, di ba? Tamang ginawa natin. From 0 to 3, negative siya. From 3 to 4, positive. Ayan. I think you have done this.
Opo.
So, integral of x squared, x cubed over 3. Ito naman, 3x squared over 2. Ganun din. Ito naman, from 0 to 3 yung evaluation. Ito, 3 to 4. So, from there, so, evaluate na natin siya. Substitute mo muna yung 0. Pag sinubstitute mo 0, 0 eh. So, ang matitira dyan yung sa 3.
Nagkamali po ako sa sign, sir. Dito po sa negative 9/2, hindi ko po siya nalagyan ng negative.
Oo.
So, hindi po siya naging positive.
Nandun pa rin sa ano. 19/3 na.
Tapos, sir.
Yun yung nandun din sa ano. So, doon lang sa sign.
Apo, sa sign po.
Sa sign lang. Okay. So, crucial yung sign, no? By the way, this slide I will upload also. Hindi ko pa siya na-upload sa... Upload ko rin to. Actually, ang dami kong slide. Kaya lang sabi ko, ano kaya mas pwedeng magandang... Okay. So, actually, ang quotation niya from Paine and Thomas pala yung gamit niya. So, therefore, let's proceed now. I think we have few minutes now. Pero, tapos na tayo. If you're being sent to a desert island, you would take only one equation with you. This will be the choice. So the derivative of the integral of f of t with respect to t is f of x. No? Kasi nga, ito yung baliktaran, no? Yung fundamental theorem of calculus. No? Dito nakabatay. So yung reciprocity of function or operation for both integration and differentiation. So the fundamental theorem of calculus states if the function is incontinuous on A on B, then the function f of x is equal to integral of A to x of f of t dt. So halos wala namang pinagkaiba yan. Yun lang variable na ano. Kasi normally yung A starting from 0 to x or to the maximum value. So no problem yan. No? And then, of course, has a derivative at every point A and B, such that if you will get the derivative of the function, that's the integral, you will arrive at the same function, or f of x. Kasi maliit. So, yan yung fundamental theorem of calculus, part 1. So, yan po yan. The first fundamental theorem. No? In-integrate natin dito. Tinago mo yung x doon, pero x pa rin yun eh. Kasi from A to x, normally 0 to, x ang matitira doon, magiging f of x pa rin yan eh, afterwards. So but when you get the derivative, babalik ka. Kasi kung wala yung derivative, f of x, capital F of x yan. No, pag ginawa mo yung derivative, ito, f of x. Of course, the antiderivative have a general solution. No? So the derivative of an integral, okay, the derivative matches the upper limit. Ayan. Yung derivative or indifferentiable variable supposedly matches the upper limit of integration. So yun yung isa doon. And then, lower limit of integration is a constant. No, constant siya. Yan. And then you have the new variable. So, nagkakaroon ng transposition from f of t to f of x pag may integration ka ng constant up or 0 normally. No, kasi pag sinubstitute mo yung constant sa variable, anong mangyayari?
0 na po.
Normally 0. Pero ito more general to eh. So lower limit of integration is a constant. Then you will create a variable. Yan. So yan yung first fundamental theory. So yan. Anyway. So yan, you could pwede pong pampag-aralan to. So halimbawa, derivative of integral from negative pi to x. So constant yung negative pi, x is the new differentiable. So the long method, so you will be doing some integration. Now, in-integrate mo muna yung cosine t for evaluated from negative pi to x. Then you will do this. So, and then saka ka magdi-differentiate. So, sine of negative pi is 0. Buti na lang. Buti na lang. No? So, ang maiiwan dyan, derivative of sine of x, which is equal to cosine x. Diba? First fundamental theorem. Bumalik. Bumalik lang siya, nagkaroon lang ng new variable.
Opo.
Alright? So, yun yung ano natin dyan. So, first fundamental theorem. So, the derivative of an integral, the derivative matches the up. So, ang consideration dito, dapat, kapag may derivative of integral, yung iyong derivative matches the upper limit of integration. So, yung dx mo dito, dapat yun din yung upper limit mo. Tapos, pangatlo, constant. Your lower limit is a constant. Pasok na yun dun sa fundamental theorem of calculus. So just, you don't need a long method. You just substitute from t, variable t, to x. That's it. That's the first fundamental theorem. Isa pa. So ito naman, constant 0, dx, dx, check. So derivative of an integral matches the upper limit. And the lower limit is actually a constant. Therefore, lo and behold, you just substitute from t to x. Right? So that's the first, the fundamental theorem of calculus. Ito naman, the upper limit of integration does not match. Kasi yung upper limit ay x squared, pero yung derivative, yung differentiable variable ay x, so hindi siya. But we could use the chain rule. Anong ibig sabihin ng chain rule? Ayan. So yung chain rule, ibig sabihin yan, pwede mong i-substitute dun sa differentiable variable mo. No, para maging akma. So yung cosine, yung t mo, you equate t to x squared. So cosine t is equal to cosine x squared. And dt is equal to derivative of x squared. Hindi mo lang sinubstitute yung t as a variable, pati yung differentiable variable na dt, sinubstitute mo yung x squared. Ayan. So, yun yung tinatawag natin na chain rule. Kaya pwede yan. So, if that would be the case, derivative of x squared is 2x, then cosine of x squared. That would be 2x cosine x squared. So, yan. So, pwede na siya. So, meron kang chain rule dyan. Okay. Yan yung sagot. Hindi ka na nag-integrate muna bago yung derivative. Hindi na ganoon. So ang ginawa mo, inequate mo yung suppose variable doon sa upper limit. Kasi dapat magkatumbas sila eh. Na dapat magkatumbas yan. No, I mean yung differentiable variable doon sa upper limit. So ang ginawa natin, pinag-equate natin yung t doon sa old variable to a new variable. So the new variable supposedly cosine x squared. Cosine of x squared. And then derivative is derivative x squared. So we need to simplify further. Okay. So ito, katulad nito. So baliktad, di ba? So hindi siya lower limits of integration is not a constant but upper limit. So but we could change the sign and reverse the limit. Ayan. Pwede na, di ba? Pwede na siya. So, kung na-reverse mo, constant yun, pwede na. So, yan yung sagot. Ang simple, no? Pero yan, because of the fundamental theorem of calculus. That's the way it should be. Ito naman, gano'n na naman. Reverse muna natin. Actually, hindi parehong constant, no? So, problema pala to. Tingnan natin. We split the integral into two parts. Yung pala, pwede. Such that it will have a constant. Isa from 0 to x squared, and then from 0 to 2x. Medyo komplikado nga lang. Komplikado siya. From 0 to x squared, gagamitin uli natin, i-equate natin yung x squared to t.
Chain rule.
Oo, chain rule. Ito naman, i-reverse natin. Magkakaroon ng negative para mag-0 yung lower limit, and then 2x, chain rule uli. Kasi hindi siya pareho-pareho. So yun, does not match. Ayan. So yan ang nangyari, negative. So, alright. So afterwards, limits were reversed. And then, chain rule. Apply. So yung t is equal to x squared, pero derivative of x squared, 2x. Derivative of 2x here, 2. Ayan. So, yung dt mo dito nabago eh. Yung dt dito, derivative of x squared. Yung dt dito, derivative of 2x. Kaya nagkaroon ng 2 doon. Ayan. Chain rule is used. And then simplifying further, we have the answer. Yeah, curious ako dito. Sige nga, ano nga natin? Subukan natin. Dali lang. Tingnan ko kung kaya. No? So, tingnan ko lang kung kaya. Diff of integ. Of.
Wala.
Tingnan ko kung kakayanin to. From 2 plus. Ano nga ba ito? Nakalimutan ko codes nun ah. T raised to ano? Pwede rin naman. Ito. PXPP. Pero hindi siya treat as constant. No? Rx pala, sorry. X. Hindi T. Wait, wala tayong, hindi pa nakasims. Diff of integ. Try ko lang I'm just experimenting here. 2 plus PXP T or X from 2x to x squared. Yun, no kayong kakasadlakan ito. 2x to x squared, no? 1 or all over 2 e raised to x. Yan, tingnan natin. Yun, walang sagot, oh. Nangyari doon. Wala siyang sagot. Nag-error, Syntax error, diff. Pwede naman, gusto mo muna, integrate muna bago i-diff. Sige, okay din naman yun. Say, integral. Sige. Yun lang, ayaw, Wala siyang ayaw lumitaw. Next time. Hindi ko alam bakit So, integral of hindi ko sure bakit
Kulang po ata sa parenthesis, sir.
parenthesis.
So, ay, hindi. Tama pala.
2x.
Ay, opo.
Gawin ko kayang e raised to x to. Pero normally, we don't do that. EXP talaga to eh. So kung ano, ito na lang. Ayaw niya, no? EXP talaga. Kaya lang pagdating dito, wala siyang ano. Siguro may limitation din to, no? Hindi kasi pare ano eh, variable din yung ano eh. Anyway, sige. Wag na. Anyway, we'll okay na to. Ito last na to, yung fundamental theorem number 2, integral evaluation theorem. Ito yung fundamental theorem part 1, more on differential of integration. The derivative or the differential of the integral, once satisfied, no, you just copy the new variable t, convert it to x. No, then we will be applying some chain rule, reverse limits, and other things. So that's fundamental theorem. And then we have the second point is the integral evaluation theorem. All right. So here, ayan, integral evaluation theorem. Parang bilis niya, no? Oh, ganun agad. Teka, wait. O, dito, di ba? So what would be the answer? 1 over x. Negative of 1 over x, di ba? Teka, wait. Parang may problema tong ano. Kanina lang gumagana to eh. Two-thirds. Ayan. Tama, 2/3. So because yung f of b niya, yung f of b, that is kung tatanggalin ko to, definite integral na to eh. Indefinite integral. No? So negative 1 over x. So negative 1/3 minus negative
1.
Minus
Negative 1.
Minus negative 1. Tama, 2/3. 2/3 pala. So it's just in-emphasize lang yung f of a, f of b minus f of a.
Okay.
So ito, sige, check na lang natin sa MATLAB. One plus. Anyway, in your free time, you could verify this. Yan. Yun, 81 over 10. Lastly, 52/3. So, integral square root x from 1 to 9. 52/3. Galing, no? Hindi ko alam kung sino mas magaling eh, yung Octave o yung PowerPoint. Yan. So may mga evaluation na lang to. No? Anyway, pwede mo namang ano yan. So ito, no? So may trigo function pa dito. So ito mga application na to, we will be somewhat discussing it by next ano na lang. Then the trapezoid rule, nagawa na natin to kanina. Yan, nagawa. Parang reiteration na lang to. Alright? Sige. Okay na. Medyo, ano na, alam ko medyo babad na tayo sa calculus. No? So, by Friday, we'll continue on this. No? We will continue.
Opo.
Just be reading, please read on area. This is already a reinforcement of chapter 2 area. And the Riemann sum indefinite integral. Marami tayong tinalakay ngayon kung tutuusin with that slide. And then 5.4, fundamental theorem of calculus. Lahat yan, na-cover natin ngayon. Tatlong portion ng chapter 5. So, konting readings ka na lang dyan. Siguro, hindi mo na mag-assign this week. Next week na ako magpapa-assign din sa'yo ng exercises. Okay, you start with reading 5.5, integration by substitution.
Okay po, sir.
Susunod na, kasi na-cover natin yung area, Riemann sum, and then fundamental theorem of calculus. All were covered by this slide. But you could still, for reinforcement purposes, pwede mo pa rin basahin yan. But our topic this Friday will be 5.5, integration by substitution. Okay? Kasi lalapit na tayo din sa mga iba pang mga methods of integration, such as numerical integration, logarithmic function, inverse trigo, yan na, hyperbolic. Yan yung mga dadaanan nating mga functions. No? So we'll be doing the substitution, integration by substitution, which is also a powerful method of integration. Okay? So yan yung ating so thank you Gillian for your time.
Thank you.
PowerPoint upload ko agad to this tonight para meron ka ring
mas madali po siya intindihan kaysa dun sa libro. Pagdating Riemann sum.
Hyper siya, medyo university level talaga yun. Saka pang 80 siya, na-discover ko pang advanced placement calculus na gamit yung libro na yan. Yan yung ginagamit sa England, yung mga AP, advanced placement. Ibig sabihin, pag nag-AP ka, honors class ka. Nasa honors class. No, may mga ganun silang treatment sa mga college. No? Kaya minsan, yung bachelor's BA, tapos may hon na nakalagay. Ibig sabihin, honors class siya. So, one of a kind yung estudyante na yan. Ganun yung ibig sabihin. So, ginagamit tong libro na to, yung book na ginagamit natin for honors and AP, advanced placement. Okay? So, thank you, Gillian, for your time. Let's close in a word of prayer. You have some comments or baka meron ka pang last so tuloy siguro yung mo yung octave, no? You could always make use of octave as your checking tool, pero dapat gagawin muna siya manually, no? Yung formula, you use the formula first, and then for checking purposes you may use octave. Okay? Okay ba, Gillian? So yun yung purpose natin. So para ka rin, ma-master, ma-detect mo agad yung error, but si octave, iba yung binibigay na sagot. Ayan. And then you could come back with your answer, solution, perhaps, identify and rectify the solution. Okay? So, hindi mo na bibigay ng exercise, no? So, but be ready with 5.5. 5.5 methods of integration. Yung kasing numerical integration na nakalagay sa book, halos yan yung trapezoidal rule. Pero dadaanan natin yan. Tingnan kung pwede pa. And then the natural logarithmic, no? Integration of logarithmic function, no? Trigonometric function, inverse trigonometric. No? Yan na, ito na yung mga transcendental functions. Kasi madali lang pag algebraic functions. Pero pag in-apply na siya sa transcendental function, nagiging komplikado ang calculus.
Opo. Ang hirap nun, sir. Naalala ko yun.
Sige. Anyway, so totoo, tatlo lang yung bulk ng So for this prelim period, tapusin natin lahat ng integration techniques. And then by midterm, applications of integration. And then yung sa finals, more on advanced topic on integration. Parang sinimplify na lang natin yung presentation. Okay? Sige, let's close in a word of prayer. Father in heaven, we thank you for this day. Thank you for the time. Thank you for the endurance you have given to Gillian. Thank you for her diligence. I pray, Lord, for your blessing and that you will continually guide her, Lord. I pray, Lord, that you'll also continue to give her grace on the ministries sa churches, ministries gawain sa iglesia, maging sa kanyang mga iba pang mga pag-aaral on her other subjects. I pray, Lord, for your guidance and mercy as well. We thank you, Lord. Glorify your name, even as we dismiss in our course this afternoon. This is our prayer in Christ's name. Amen. Ay, ano nga pala, solid din, no? Part ka na solid. Plain and solid.
Apa.
So that
Apa.
would be from 8 to 9:30. Paano pala yung
Paano
Edu
po?
115 mo? Na-chap-chap pa rin?
Ano po, sir? Yun pala. Ano na lang po, Edu 115. Wait lang, sir. Nagulat tuloy ako sa skin.
Di ba nag-exit ka nung earlier?
Opo, tuwing Friday po. May trigo po kasi ako ng Friday.
Okay.
Ng 10:30 to 12 po. Parang yung latter part po.
Pag ganyan, ang solusyon ko, magsabado ka na sa akin together with the CTP class. Kung available
Anong
ka
oras po yun?
7 to 10.
Wala, sir. Meron ding kasabay.
May kasabay. Yun na lang kasi yung choice eh. Mahirap kasi kung kalahati lang yung ano mo. Ano kaya?
Yung Edu 115.
Oh yes. Gillian, are you still there?
Hello po.
Yes. Go ahead.
Yung Edu 115 Friday na po.
Ulit.
Tama po ba? Yung Edu 115 po. Friday na po siya, no?
Oh, Friday, 9:30 to 12:30.
Oh.
Kaya kung 8:30, 10:30 ka mag-exit, medyo kapos yun. Kasi normally, tumatanghali talaga ako eh. Tapos pag Sabado, may konti ka rin. Hindi rin pwede.
Opo, kasi pag Saturday po, meron po akong 9:30 to 12:30 din po.
Naku, sabay na sabay.
Parang kapag Sabado po, parang 30 minutes po akong mawawala sa dulo. Tama po ba?
Pag Sabado?
1 hour.
7 to 10 lang yung schedule ko eh, pag Sabado. Anong schedule mo pag Sabado? O pag kasi, halos isang oras ka lang nasa Edu 115 from 9:30 to 10:30. Tapos you'll go to your Trigo class. Ang mangyayari niyan, talagang aralin mo na lang yung recorded session. Kasi hindi naman talaga original na schedule to eh. From Thursday ang original schedule ng Edu 115 eh. Palagay mo, Gillian, what do you think? Hello, Gillian, are you still there?
Hello, sir?
Yes. So, you could decide.
Ano na lang po, sir?
Friday, no? Friday ka na lang talaga.
Pwede po Saturday po, sir. 7 hanggang 9:30 po makaka-attend po ako. Yung last 30 minutes po, yun po yung...
Ayun, mas madami kang makukuha doon kumpara doon sa isang oras lang na 9:30 to 10:30.
Opo. Saturday lang po ako a-attend, sir.
O sige, this Saturday. Kasi...
andun din po si Ira, no?
O, si Ira din nandun eh. Kasi mayroon din siyang conflict sa schedule.
Din. Oo nga po eh.
Sige,
yun na lang
Sabado
po,
na
sir.
lang. Tapos,
Apo.
disregard mo na yung module na inassign ko sa'yo kasi maiiba yun. Magbubunutan pa lang kami Sabado
Opo, sa reporting pa.
sa
Sige
reporting. Sige, Saturday na lang.
Apo.
Pero kita tayo ng solid, saka ng calculus ulit. Week number 2 naman.
Opo.
Sige na. Sige, God bless.
Sige po.
Bye-bye.
Thank you, sir. Bye-bye po.